Good morning, class. Today is January 14th, 2022, and that's an e-learning day for you. So if you're watching that today, you are at home and it's cold outside. If for some reason you're watching this in the future, then hopefully as you find this video helpful about using trigonometry to find side lengths, okay? Those of you watching today on your e-learning day, though, I do want you to take these notes down in a notebook, please. Then we'll probably have an assignment for you when you come back. All right. So there's some steps on your screen as to how to do this. How do we use trig to find the side lengths that are missing? Okay. You remember in our previous lesson, we found trig ratios, and we're going to use those again to help us with these missing side lengths. So the first step is we have to determine which trig ratio to use based on what we're given. All right. Then we're going to set up the trig equation. And then lastly, we're going to solve. So for example, in this one, this is number 5 because I think we did 4 problems the other day. We are given that this angle down here is 55 degrees. In the previous ones, we were just finding ratios. We used the Greek letter theta to help us out. Okay, here we're actually being given what that value is. In this case, 55. And compared to that 55, I have the opposite leg as well as the adjacent leg. Adjacent, remember, just means next to. So using our Sohcahtoa, right? It's important you spell this word right. Oops, I about messed up there. Compared to the opposite and the adjacent, well, the O and the A, opposite adjacent, that's going to be with our T, which stands, of course, for tangent. So let's write this out. Let's say tangent of our angle, 55, equals, and then we're going to do it in that order, O over A for the trig ratio. And the O here is what we don't know, that's our H, right? Across from that, and our A, the adjacent side, is 45. Okay, so how do I solve this? Well, the variable that we're looking to find here is H. And so to get that H isolated, I need to actually multiply both sides by 45. So you will need a calculator today that can do trig functions. And preferably you can type it all in on one line so it's a little bit easier for you. There's some online calculators that do it pretty well if you don't have one. In this one, what I'm going to do is in my calculator, I'm going to type in, just like it looks, 45 tangent of 55, hit enter. I'm doing it as we go along here, and then we get 64. Let's round to the nearest, let's go nearest 10th today. We'll keep it nice and easy. So I got 64.2666, and this becomes just 64.3 after rounding that, and that is going to equal over here my H. All right, and that's it. All right, let's try another one. This one, number 7, we'll go a little faster. Did we skip 6? I don't know why there's not a number 6, but we'll try number 7. Number 7 says D on the left side and 8 on the top for our hypotenuse, and then we have this 34. So again, all kind of hinges based upon the angle that we're given, in this case 34. Compared to that, the other information that I see is across, that's our opposite side, and then our hypotenuse. Remember, the hypotenuse is always across from our right angle. So again, if I write out Sohcahtoa, right up there, the one that uses the opposite and the hypotenuse compared to my angle, OH, that's going to be my sine function. All right, so I'm going to say sine of my angle, sine of 34, equals, and then I have to do it in that order, O and then the H. Well, the O, the opposite side here, is D, and the H, of course, is my hypotenuse, 8. And again, to solve for the D value, that's my variable I'm looking for, I have to multiply both sides by 8. And in the calculator, I'm going to do just like it looks, 8 sine of 34 equals the D. And let's see here, 8 sine of 34, type in my calculator, is 4.473. So if I round, I think that's going to be 4.5. 4.5 equals D. Okay. Now, one way you can kind of check this if you put it back into your problem is, remember, our hypotenuse is always going to be the longest side. So as long as this is smaller than that, we probably did it right. Okay. Let's try number 8. Number 8, this one, our angle that we're given is 37 degrees. Compared to that, I have my opposite leg as well as my adjacent leg. So OA, that's going to be TOA, T-O-A, and our Sohcahtoa, which means I need the tangent. So I'm going to do tangent of 37 equals my opposite T over the adjacent 4. All right. Opposite t over the adjacent 4. Multiply both sides by 4. And on this one, I'm going to type it in just like it looks. 4 times the tangent of 37. And when I do that, I'm left with 3.014. So that just rounds to 3.0, or you can just say 3. And on the right side, I should say, I'm just left with a t. Okay. So I think we're good to go for that one. All right, let's try now we're back to number 6. I don't know how these are numbered, but hopefully you guys are getting it all figured out in your notes. Okay, here I have another 34 degrees, and compared to this, I have my adjacent 15 and my hypotenuse x. Good, I'm glad we have one like this. This is where it starts to get a little bit tougher. Okay, so again, compared to my my angle, I have the adjacent and the hypotenuse. So real quick, if I write this out, Sohcahtoa. It's important you spell this word right. Sohcahtoa. The adjacent and the hypotenuse deals with the cosine, C. So we're going to do cosine of 34 equals my adjacent side 15 over the hypotenuse x. Now, up until this point, what we've done is multiplied to get the variable isolated over here. We are not going to necessarily do that in this one, okay? The biggest mistake that I see students make is they try to multiply this side by 15, and that is absolutely wrong, okay? That does nothing to help me, because then my x would still be in the denominator, right? So instead, we have to get our x out. This one's going to take 2 steps. So I actually have to multiply by x, okay? And you'll notice on the left side, my x is not isolated, all right? I have to do one more step with it. It actually equals 15 over here. So x times the cosine of 34 equals 15. How would I get my x isolated? Well, in one more step, since it's currently being multiplied by the cosine of 34, I can divide by the cosine of, not cosine of cosine, cosine of 34. And I have to do that to both sides. Okay, dividing by a cosine is an absolutely fine math maneuver to do. This is going to give me x equals, and then on the right side, 15 divided by cosine of 34. Hit enter in the calculator, and now we're going to see this is 18.09, and if I round, 18.1 for x. Okay, again, one way you can check yourself is if you did mess this up over here, you should see that when you put it into your hypotenuse, that needs to be the longest side. So 18.1 is definitely longer than 15, so I know I did it right. If you were to mess it up and get something smaller than 15, well, the hypotenuse cannot be smaller. So double check your work that you did that correct on that problem. All right, number 9. This time we're given the angle 72 down here, and we need to find both x and y. So let's do it in alphabetical order. Let's find the x first. And compared to this x, the only other information that I know is the 3. Okay, I don't really have any idea what y is yet. We'll get there eventually, but compared to the 72, I have my opposite and my adjacent, which is going to be TOA, OA, TOA, or tangent of 72. And tangent of 72 equals the opposite's x over the adjacent 3. This is one of those easier ones where you can just multiply both sides by 3. And that's going to get my x isolated, which is good. And on the left side in the calculator, 3 times tangent of 72 is 9.23. So I'll round it. It's just going to be 9.2. Just like that. All right, so I'm going to write that in over here, 9.2. And then I'll switch colors. And this time, I'm going to erase this because we have to find y. We found x, and now we have to find y again. And compared to my 72, the y is the hypotenuse. And then I'm not going to use this rounded value. What I'm actually going to use is the 3. Okay, that's going to give me a little bit more of a nice answer. And 72 degrees there in the corner. The 3 is the adjacent leg compared to that, and the hypotenuse is our y. So what uses the adjacent and the hypotenuse? Which trig function? It's going to be cosine. So let's say cosine now of 72 equals, let's see, equals the adjacent 3 over the hypotenuse y. This is one that's going to take 2 steps. If I multiply both sides by y, always multiply what's in the denominator. There's maybe one rule you can follow. And y times cosine 72 equals 3. So to get my y isolated, I have to divide by the cosine of 72 on both sides, cosine of 72. So those are going to cancel on the left side. On the right side, in the calculator, 3 divided by cosine of 72 is 9.708. So I'm just going to say 9.7. And when I put that in here, 9.7. All right, good. I'm noticing something right away, and that is that my hypotenuse, my angled side, is definitely the longest of the other ones, right? I have a 9.7, 9.2, and 9.3, so the 9.7 hypotenuse is the longest side. All right, number 10, and then I think, yep, that's the last one. Number 10, let's find another x and y in this problem. Feel free to pause and try it on your own if you think you got a good handle on this. Otherwise, you can keep following along with me. In this one, we have our 50 degrees. And again, I'm going to do this in alphabetical order, x first and then the y. So compared to that 50 with my x, the x is the adjacent leg. And I also have my other information over here is the hypotenuse 12. So we just did one like this, the adjacent and the hypotenuse. That's our cosine function. So we'll say cosine of 50 equals the adjacent x over the hypotenuse 12. This is one where you can just multiply both sides by 12, and that should get us pretty close to the answer. And in the calculator, let's see, x is over here. In the calculator, 12 times cosine of 50. Oops, typed it in wrong. 12 cosine 50 is 7.71. So we can just say 7.7 for x. And I'll write that over here, 7.7. All right, switching colors now, and I'll erase this information. Switching colors to blue, we have 50 degrees, and now I need to find the y. So that's my opposite, and then I still have the 12 as my hypotenuse. Opposite and hypotenuse is sine function. So sine of 50 over, let's see, or sine of 50 equals, I should say, the opposite y over the hypotenuse 12. Okay, this is another easy one because I can just multiply both sides by 12. And when I do that, we're left with a y over here. And then in the calculator, 12 times sine of 50. And that's 9.19 or 9.2 if I round that just a little bit. 9.2. Okay, again, double check your answers. Make sure that your hypotenuse, in this case the 12, is our longest side compared to the other ones we found. And it is, so we probably did this one correctly. All right, guys, that is your assignment today, is to get those notes taken. Also post some other videos if you need those as well. Otherwise, we'll do an assignment on this when you get back to school. Have a great e-learning day. See you in the next one.